Hello, welcome to the lecture on groundwater. Groundwater, as we know, is the water that is occurring below the groundwater table. So when we say that, we may be having a doubt. So all water that is occurring below the subsurface is not groundwater or what? It is not groundwater. Strictly speaking, all the water that is occurring below the surface of the earth is subsurface water, but not all subsurface water is groundwater. But all groundwater is subsurface water, definitely. Because we know groundwater is occurring in the zone of saturation. The water that is occurring in the zone of saturation is called groundwater, and the upper surface of the zone of saturation is called water table. Okay. And now coming to the importance of groundwater. Groundwater is found in the pores of soil and sediment plus narrow fractures in bedrock. We know that. In the case of sediments and sedimentary rocks, it is occurring in the pores of the material, whereas in the case of hard rocks, let it be the igneous rock or sedimentary rock, any type of that where there are no pores, but it is occurring there in the secondary porosity developed by the fractures in the bedrock. And of course, groundwater is the largest reservoir of fresh water that is readily available to humans. And the importance of groundwater as a geological agent is that it is an erosional agent and it serves as an equalizer of stream flow. How? That we will see. That is the concept of effluent stream and influent stream. When the water is when there is no enough water in the streams, the groundwater may be supplying that and making the stream an effluent one, and sometimes the reverse flow may be there, water may be supplied to the wells from the stream. Then we call that as the influent stream. And these things may be slight variations may be there, but you might have seen in different books and the materials that is available. While the percentage of water that is available to humans is very less. And distribution of groundwater, or the vertical distribution, is like this. The zone of saturation, the water reaches a zone where all of the the open spaces in sediment and rock are completely filled with water. Water within the pores is called groundwater. Water table is the upper limit of the zone of saturation. And in the case of the zone of aeration, or the upper part of the vertical, when we consider the vertical distribution of groundwater, we have the zone of aeration, and the zone of aeration has got three parts. Starting from near to the surface, we have the zone of soil moisture. Below that we have the intermediate zone, and just below that the third zone is the capillary fringe. And why it is called capillary fringe is that it is extends upward from the water table. It is receiving water from the water table, and it is the water is moving up by capillary action. Groundwater is held by surface tension in tiny passages between grains of soil or sediment. Okay, and that will be sent up by the capillary action. And the zone of aeration is, as we know, it is the area above the water table. It includes the capillary fringe and the belt of soil moisture. Water cannot be pumped by wells. That is, from the zone of aeration, there is no enough water. Definitely water cannot be pumped by wells. And this is how we can say, if we say this is the zone of saturation, this is the capillary fringe zone, in between we have the intermediate belt or intermediate zone, then we have the zone of soil moisture, and this is the zone of aeration. Here we have the zone of saturation. Okay, this is the water table here. Okay, and the water will be available in the pore space between the grains. Okay. And the water table is the upper limit of the zone of saturation. Variations in the water table will be there. Depth is highly variable, and then we say that the water table is a replica of topography. And when the topography is high, water table will also be high, and when it goes down, the water table normally it follows the topography. That is why we say water table is a replica of topography. And variations in the water table. Factors that contribute to the irregular surface of the water table are water tends to pile up beneath high areas, that is, large areas, water will be more. Variations in rainfall is another reason. When there are more rainfall, of course, we can expect more groundwater also. Variations in permeability from place to place, that is another reason. Even if enough rainfall is there, if the rock is not permeable, if the surface material is not permeable, what will happen is the water will be escaping as surface runoff. No groundwater recharge will be there. Interaction between groundwater and streams constitutes a basic link in the hydrologic cycle. Three types of interaction, that is the gaining streams or the effluent streams, that is gain water from the inflow of groundwater through the stream bed. And we have the losing streams or the influent streams, lose water to the groundwater system by outflow through the stream bed. They are called the losing streams or influent streams. This is the gaining stream, you can see the effluent stream, that is receiving water from the water table, and then we have the losing stream or the connected ones, that is water is supplied to the wells from this one. The influent stream or the losing stream is because the name has come because the wells or the water table is influenced by the streams, that is why they are called as influent streams. And there is another chance that there are influent streams but there is no connection, even though the water is lost from the stream, but that is not directly connected to the water table. So there are two types of losing streams, connected and disconnected. Okay. So interaction between groundwater and streams is that a combination of the first two, that is a stream gains in some sections and losses in other areas. And the factors influencing the storage and movement of groundwater. What are all the factors? One is of course the porosity, the percentage of total volume of pores that determines how much groundwater can be stored. Variations can be considerable over short distances. And this is the condition, selected values of porosity, specific yield and specific retention. We will be coming to these two terms. Yeah, that is specific yield is nothing but it is the volume of water that is an aquifer can give, or the volume of water that can be yielded from an aquifer, by means of by the force of gravity alone. That is what much volume of water can be attained from a particular aquifer is that is called the specific yield. And specific retention is the volume of water that will be retained by an aquifer against the force of gravity. So we can see that the volume is determined by the volume of pore spaces, because when pore space is there only you can have water in that, and then that water can be yielded or retained by the aquifer, or yielded from the aquifer or retained by the aquifer. So we can easily find that porosity will be nothing but it is the sum of specific yield and specific retention. You can see here also, you can see the soil material is soil, porosity value is 55, specific yield is 40, and the specific retention is 15. 40 plus 15, 55. In the case of clay has got a very low specific yield, but the specific retention is more. That is why we call clay as an aquiclude. It can hold water but it will not be transmitting water. That is why we say specific retention is more, specific yield is very less. 48 plus 2, it is 50. Like that, for all it is like that. Porosity is like that. Okay. Now, factors influencing the storage and movement of groundwater. One is the permeability, the ability of a material to transmit a fluid. That is determined by the connectivity, interconnectedness of pores in the aquifers. Okay. And these aquifer types we will be seeing again later. And there are different types of material. One is an aquifer, which can hold and transmit water. Aquitide is an impermeable layer that hinders or prevents water movement. It is not clay actually, it is aquiclude. Here clay is an aquiclude. Aquitide is retarding the movement of material through that is silt material, silt stone, etc. It will hold water, it will transmit water, but the movement will be limited. Then the aquifers are there, different types of aquifers we will be seeing in detail later. And movement of groundwater will be exceedingly slow. Typical rate of movement is a few centimeters per day. That is what we have to understand. Exceedingly slow rate of movement is there as far as groundwater is concerned. Energy for the movement is provided by the force of gravity. And the important law that is dealing with the movement of groundwater, the fundamental law is Darcy's law. So that we will be seeing in the next lecture. Starting with Darcy's law, we will be moving to the other groundwater flow equations and all. Okay, just we will see what is Darcy's law. If permeability remains uniform, the velocity of groundwater will increase as the slope of the water table increases. We can say it in different ways. We will see that in detail in the coming lecture.